So well done, excellent work, and hopefully you learned a bit about the footprint area and how easy or hard it was to build a tall skyscraper. So we had our New York example here. And hopefully as well what you've realised is that skyscrapers actually need that bigger footprint. That's why cheerleaders have, if they're building a human tower, have a bigger base and going to a smaller top. Now this is a home insurance building built in Chicago in 1885, and it's probably one of the first modern American skyscrapers, but it would be dwarfed by our modern skyscrapers. It's tiny in comparison. They would use steel and cement, and this is still used today, but obviously they need to withstand lots of things like wind and other forces. Our skyscrapers also had some wind to deal with, so let's have a look at how skyscrapers are built to deal with wind.
Wind is one of the most important factors that architects and engineers must consider when designing tall buildings. While skyscrapers might appear to be highly strengthened, immovable structures, all tall buildings are in fact designed with a degree of flexibility in mind. This is principally due to the impact that wind forces, known as wind loads, have on a building as it becomes taller. Whilst you might be experiencing a pleasant breeze at street level, the force of the wind generally grows much stronger the higher up you travel. While the steel and concrete used in a skyscraper's superstructure is designed to bend and flex to absorb the impact that these wind loads have, the degree to which a structure is able to move can have a significant impact on the comfort of those inside the building. When buildings first began to grow tall in the 1890s and 1900s, height limits were imposed, such as those introduced in Chicago, to prevent their masses from blocking sunlight. In New York City, ordinances were passed that allowed tall buildings to develop on the basis that they were set back after reaching a certain height. This allowed sunlight to reach street level, whilst breaking up the facade and reducing the impact that high winds had on these early towers. By the 1960s, however, larger box-like skyscrapers began to come to prevalence, bringing with them a whole host of wind load engineering challenges. The first problem that began to arise was increased wind velocity at street level. This was principally caused by the street canyon phenomenon, an effect that sees large buildings redirect wind down their facades, which effectively act like canyon walls, and funnel it along streets at much higher velocities than in low-rise suburban areas.
If you're interested in building skyscrapers, maybe a job in architecture or engineering is for you to look forward to in the future.